Here is the second problem example for the benefit-cost ratio analysis. This example includes multiple elements from previous chapters and is more complicated than the previous problem. I suggest you first can take a few minutes to read the problem and try to work it out for yourself, and then watching the video to see how this problem can be solved. Now let's get started. So this problem wants us to calculate the benefit-cost ratio. In order to do that, we need two pieces, the benefit part and the cost part. And here, I'm going to use a different way to calculate the cost and the benefit. Now, I'm now using the present worth method. So the only revenue can be obtained from this sentence in this problem. So revenues generated from the tolls are anticipated to be 2.5 million in its first year of operation, with a projected annual rate of increase of 2.25% per year due to the anticipated annual increase in traffic across the bridge. So what does this imply? Something familiar to you in the previous chapter? Yes, this is a geometric gradient series. Now, just a little recap for the difference between the uniform gradient series and the geometric gradient series. Now we have on the left side as the uniform gradient increase cash flow, and notice the first year is 0. And on the right side, we have the geometric series, and the first year we have the original payment, which is A1 here, and that can not be 0. So on the increasing part, the uniform gradient increases with a fixed amount of dollars, G, and on the geometric sequence part, it increases by a fixed rate of some percentage per period. So how do we calculate the present worth of the geometric sequence? So now we have the equation to calculate the present worth of the geometric sequence, and on the upper part underlined by the blue line, when we have unequal discount rate I and constant rate of F bar, then we use this guy. And if we have the same discount rate and increased rate, which is when I equals F bar, then we use this guy below. And now for this problem, since we have the increased rate, F bar equals 2.25% and I equals the discount rate is 10%. So we're gonna stick to this upper equation here. Now to calculate the present worth of benefit, we just plug the numbers to the upper equation, and we have A1, which is 2.5 million, and I equals 10%, and F bar, the increase rate, is 2.25%. And N, so we have 30-year project life. And we just plug in those numbers. We have this guy times 1 minus P given F, 10%, 30-year, and F given P, 2.25%, 30-year, and divided by the discount rate, 10%, minus the fixed increase rate, 2.25%. And we can get about like 28 million. So 28,654,750. And that's the present worth of the benefit. Now we want to calculate the present worth of the costs. And here we have three parts. the first one, initial investment, which is 17,500, 0. And we have the operating and maintenance costs, which is about 325,000 annually. This is annual cost. And the resurface costs, which is 125,000, and that's actually paid every 5th year. So you might be wondering, like, this guy here is really bizarre. How can we calculate this cash flow, like paid every 5th year? And don't worry, we have some tricks to deal with it. And if you have attended the previous problem sessions, you might be familiar with this technique. So let me just first draw a cash flow diagram only for the resurface costs. So we have the 0, year 1, 2, 3, 4, 5. So the 5th year, we have the payment here, and 6, 7, 8, 9, 10, and we have another payment, and this will continue until the 25th year. Remember, in the problem, it says the resurface cost is not counted at the year 30, so we can just stop at year 25. So the trick is to flatten this 5th year payment, this arrow, to each year. So we're going to have this small annual equal payments at each of the year in the 5 years. And just for the same first 5-year period. And we're going to repeat this process for the entire horizon. So to do that, so we have, this is the future value of the 5th year. So we want to calculate the annuity. So A given F, and we have the discount rate 10%, and we have because the future value is paid at the 5th year, so we have N equals 5, and times the given future value. That's the 5th year payment, which is the 125,000 here. And by doing this technique, we can convert the 5th year payment to annuity. And we just need to do this one time because we already transferred the 5th year payment to the annuity, and the annuity should be applied for the total time horizon, which is 25 years. And to get the present worth of these annuity, then we further apply this factor. So we want to calculate the present value given the annuity, and we have the 10% discount rate, and for 25 years, since we want to get the present worth here. Then to calculate the total present worth of the costs, it should be very straightforward. So we have 3 pieces. So the first piece is the initial investment. So it's already paid on the year 0, so we don't do anything. We just put the number here. And then the second piece is the annual operating cost, so we need to convert that to the present worth. So we have the annuity, so 325,000 times P given A, since we have the annuity, and 10% in discount rate in 30 years. So remember, this operating and maintenance cost is there for each year. And then we have our the final piece. We have just down above. So we have 1, 2, 5, 0, 0, 0. This every 5th-year payment, and we convert that back to the. Oh, sorry, just move that to the bottom because I don't have space there. So I just convert that 5th-year payment to the annuity, and I times by the. So annuity, I'm gonna get annuity given the future value, and 10% discount rate, and for 5-year period, and that will be the annuity for all the 25 years. So we want to get the present worth, so we times present worth. We want to calculate present worth given the annuity, and we have discount rate 10%, and for 25 years. Now, so the whole piece will get us the value of present worth is 2242258. Okay, now we have all the ingredients ready. We just continue to calculate the benefit cost ratio, which is B divided by C. That's just P present worth B divided by present worth C. We'll just plug in the numbers. The first one, 2A65470, and this guy 2242225A, and we have this guy equals 1.8, which is obviously greater than 1. So this project is acceptable. And then we conclude the second example problem.